Alright folks, what I'm going to be doing now is working through test number 1. What I'll do is work through the test in a very slow and deliberate way, working through every single detail that I can think of. This is probably not the way I would do a test in practice, but it will be helpful for you really to see how the thought process can go, because people take different tracks as they try to solve problems. Okay, first of all, name James Oneless. Here we go. And the first question is a multiple choice question. Circle the best answer. Each question is 10%. The slope of a line connecting 2 points on a velocity versus time graph gives A. displacement, B. average velocity, C. average acceleration, D. instantaneous velocity, E. instantaneous acceleration. We've got a velocity versus time graph like this, and what we're going to have to do is look at the graph. Maybe it's something like that, could be anything, and they say we're trying to find 2 points, so 1 point over here, let's say, and another point over here. You can see the instantaneous velocity is the actual slope, right? So the instantaneous velocity would be increasing as you go like this, and then decreasing as you go like that. So between these 2 points, between here and here, this is delta V, this is delta T. The slope of a line connecting 2 points on a velocity versus time graph, then what's that going to give us? So velocity divided by time, that's meters per second divided by second, that's the units. And those units would be meters per second squared. That's an acceleration. So it could be this one, C. Instantaneous velocity, no, we said no. Instantaneous acceleration, no, that would be at exactly at this point, or exactly at this point, or exactly at any point along this curve. So it's not instantaneous acceleration. I always like to, if I don't know the problem exactly, if I don't know the answer, then I'd like to eliminate, and in this case I've eliminated everything, so it's obviously going to be C. But let's just think through that. Average acceleration is acceleration between 2 points. So at this point here and that point there, time t0 and time t1, that's t1 minus t0 is our delta t that we've worked out. Delta v is v0 and v1, those 2 points there and there. So delta v over delta t is an acceleration, that's the units, meters per second squared, and it's not an instantaneous because it's over quite an extended period of time, delta t. It has to be C. That's the answer, that's the boxed answer. Question 2. A Bugatti Veyron EB 16.4 can accelerate from 0 to 26.8 meters per second, that's 60 miles per hour, in 2.46 seconds. What is the average acceleration during the time interval? A good practice, at least the practice that I find that allows me to keep my sanity when doing these physics problems, is to always write out what you know. I don't fret about trying to figure out the problem. I find that if I do that, I can lose my mind really quickly. And the best thing always to do is just write down what you know. And that always pays off in the end, even though it seems like you're taking more time. Well, I know it's a Bugatti Veyron, that's irrelevant. Could be anything. The important thing to realize in physics problems is to generalize. So we've got some car, all right? Could be an animal, could be blood flowing in a vein, could be an electrical impulse accelerating through the body. It doesn't matter, right? So it accelerates from 0 to 26.8 meters per second. Okay, so we know what the initial velocity is, right? The initial velocity, we'll call that v0, let's say. That's 0. And the units are meters per second. Always put your units in. If you don't put units in, you lose points. There was a satellite that crashed once into the surface of Mars because one group of people at JPL were using SI units, I think, and the other group of people at Houston, NASA in Houston, were using the British imperial system. of units, and somebody said stop at 100, and were they talking about miles or kilometers? Well, oops, they stopped too late and smashed into the surface of the planet. So you have to have your units. Always put your units in. We know V1, 26.8 meters per second, and the time taken is delta t, that's 2.46 seconds. What's the average acceleration? So the question that we're asking is, what's the acceleration? So here you have a good policy. Write down everything you know, write down what you want, put a question mark next to that. If you like cooking, then you have an analogy, because you can put all your ingredients on the shelf, and the nice thing about that is you can see what you have, and now you can see what you can possibly make. Can you make pizza if you don't have any dough? Probably not. So let's see. We have V0, V1, so we can get delta V. That's going to be 26.8 meters per second minus 0 meters per second. And we've got delta T. So what's the average acceleration? Well, if you know your definitions, average acceleration is equal to just delta V divided by delta T. And therefore that's going to be 26.8 meters per second divided by 2.46 seconds. We'll run that out. Done. And that's the correct answer. All right, question 3. Assuming constant acceleration, how far does the car travel? Constant acceleration would be this kind of thing, right? That means the velocity time graph would be, let's see, it starts at velocity 0. It would be like that, straight line. I don't know that that's relevant. I'm just writing down stuff I know. It's kind of like a comforter. It makes me feel a little bit happy and confident that I know what's going on if I can kind of understand. I'm trying to extract all the information from this question. Assuming constant acceleration. It's like a mystery, right? Physicists are looking at problems and trying to see all the possible information in order to simplify the way of working out the solution to whatever the problem is. How far does the car travel? So we're trying to find out a displacement. We're trying to find out a delta x. That's what we're trying to do. So these are all the things we have. We've got initial, final velocity, change in time. We also worked out the average acceleration. So we've got that, the initial. We've got v final. We've got delta t. We've got acceleration. We want to find delta x. All right, well, this is a one-dimensional problem, so I can look at my one-dimensional equations on my formula sheet, and I'm basically looking for an equation that has maybe these things, or one or more of them, combinations perhaps. We have delta x, which is final position minus initial position, equals vx0t plus half at squared. X minus 0, because that's our starting position, is equal to vx0. We already worked that out just a moment ago. We start from rest, right? Therefore we know that this is going to be 0. So let's go and put that in. So that's 0 times the time for the entire interval, and that was, where is it, 2.46 seconds. Well, 0 times anything is 0, but I'll put it in. 0 times 2.46 seconds plus, that's seconds, half acceleration, that is 10.9 meters per second squared, times t squared, the time taken for the entire thing that we're looking at, 2.46 seconds squared. Let's see, if we work that out, that works out to be x equals 33 meters. Done. All right, now, while hiking along the top of El Capitan in Yosemite National Park, you accidentally kick a rock from the tallest part of the rock face, which is at a height of 914 meters. Don't do that. But anyway, you did it. So for the questions below, assume no air resistance. Okay, good. We're simplifying the problem. How long does it take the rock to fall to the bottom of the cliff? So I like to draw a picture. The key here starts from rest, so it's kind of like the rock just falls straight down. There's no parabolic motion or anything like that. It's just straight down. We're making it simple. You always need to choose your coordinate system. So I'm going to choose my coordinate system with this point as the origin. So this is my x-axis. That's my y-axis. So that's the 0 point right over here. Boom. And that means that you start at y equals 914 meters. And you're going to end right over here. It falls straight down at what value of y? You end at y equals 0. And x 0, you start at 0. And I guess the final x value is 0 as well. Not very exciting. Acceleration in the x direction, nothing. Acceleration in the y direction. The acceleration is due to gravity, so that's 9.8 meters per second squared. That's the size. Now, which way is the gravitational force pulling you? Is it pulling you up or down? The answer is down. Therefore, that's got to be minus 9.8 meters per second, because in our picture over here, we said up is positive. Okay, take your time. Always take your time. Write down what you know. Write down what you know. Think through it very carefully. Is there anything else possibly that I'm forgetting? Because often, if you don't write down what you know, you start searching for equations, and then you start spinning your wheels, and the rubber's burning, and you're not getting anywhere. Once you're sure that you've written down everything that you might need, and everything that you actually know about the problem, even if it's irrelevant or redundant, everything that you know, then you start searching for the equation. You start trying to find the way to solve the problem. What am I trying to find? How long does it take? That's basically a time I'm seeking. I'll assume I start at time t equals 0, right? Okay, what are my equations? I've got displacement equations. I've got, for example, y minus y0 in the y direction is equal to vy0t plus half ay t squared. Of course, I've got the same thing for the x equation. X minus x0 equals vx0 t plus half ax t squared. So that's useless. 0 equals 0 plus 0. Cool. I'm a genius. 0 equals 0. Not helpful at all. Box that away. Another key when you're doing problems is not to fret, right? I just spent a bunch of time doing these equations and then finding out that it really didn't help. No problem. Just move on to the next of your equations. Something's going to work. If you choose a wrong equation, it's not wrong. It just didn't give you any information that was helpful to solve the problem. Just move on. Just keep moving. Don't fret. Just keep moving. Now, so sometimes what I will do in a test is actually look through all the questions first of all, and then I'll choose the easiest ones, the ones that at least I think are easiest, and I'll work on those. And if any of them start really bugging me and I start feeling stressed, I'll just move on to another question and get back to it if I can. All right, so I'm going to move on to this next equation then. I wrote down both of those. I decided to start with the one with x on the right-hand side, and that wasn't helpful. So I'll move on. So let's look at y. I got y0. I've got y, got ay. So let me see in this equation. I've got y0. I've got y. I've got vy0. Oh, I didn't write that down. See that? That was naughty of me. I didn't write down the things that I knew. Sometimes we forget, don't we? Vx0 equals 0. We said we start from rest. Of course. Rest means velocity 0. I should have written that down. Naughty, naughty. That could have hurt, but by looking at the equation, I realized I made that mistake. So good. I do know that as well. IAY, do I know it? Yes. Alright, so the only thing I don't know in this equation is t, which is perfect, and I can solve for that. So let's put all the numbers in. Y minus y0, so 0 minus 914 meters equals 0 times the time plus half the acceleration in the y direction, minus 9.8. And that's, of course, meters per second squared times t squared. Therefore, minus 4.9 t squared equals minus 914 meters. And we can go ahead and plug this in. Therefore, t squared is equal to 914 meters divided by 4.9, and the units t is equal to 13.7 seconds. Question 5. What is the vertical speed of the rock at the moment it reaches the ground? Okay, once again, we're going to have to look at all the things that we have. And right now, we've added a few things. So we know now as well the time that it takes, 13.7 seconds. Is it worth jumping off Yosemite without a parachute? Definitely not. You're only going to get 13.7 seconds of fun flying through the air before you have a sudden stop. What is the vertical speed of the rock at the moment it reaches the ground? So it's falling down, and we're trying to find Vy at the moment it reaches the ground. At the start, Vy0 equals 0. And let's see, I've got the time over here. So let's try to choose an equation. I know that Vy equals Vy0 plus Ayt. I've got that t. There. Of course, I know the acceleration due to gravity. I know we start from rest, so okay, great. I can find Vy. That's what I want to find. So we just go ahead and plug everything in. Plus minus 9.8 meters per second squared times 13.7 seconds. And that is minus 134 meters per second. If you wrote down Vy is 134 meters per second, of course, you'd get that right because the question was vertical speed, and speed is a scalar, not a vector. If I asked you for the vertical velocity, that's what you really found. It's Vy is minus 134. In other words, it's 134 meters per second speed downwards. Either one is going to get you points in this problem. Question 6. Vector A, that is minus 2 in the x direction. So that's, let's see, make an axis. That's y, that's x. Let's make that 1, 2. If we draw the unit vectors, that's 1, 2, 3, a j hat vector like that, minus 2, x hat vector like that, and we can do them head to tail. Head to tail, we'll move this y vector, we move it there like that, head to tail, and the resultant vector, of course, then is going to be from the start of the first to the end of the last vector. And if we look at that, that's a 90-degree angle. So this thing has a length of 3, this one has a length of 2. Question. See, I haven't even actually looked at what the question is. I'm just writing down everything that I know. Trying to get a picture, again, like you're baking or cooking or something like that. I've just gone, somebody's asked me, hey, make me something. So I put everything in the fridge on the counter and it's all in front of me. Now I say, oh, okay, what do you want to eat? And now we're going to figure it out. Determine the magnitude and direction of the vector. So this is that vector going up like that. That's vector A. This is going to be AY. This is AX. So if AX is equal to minus 2, AY is equal to plus 3, then the magnitude of A is just the square root of AX squared plus AY squared, which is equal to 2 squared plus 3 squared, which works out to be 3.6. Okay, 3.61. So now let's look at the answers. Let's just see if we can eliminate something. It's not C, because that's a magnitude of minus 1, which doesn't make any sense. Right, you can't have negative magnitudes. And 5. And the 3.6 makes sense. So it's either A or B or E. Okay, so now we got to figure out the direction. 56.3 degrees counterclockwise from the positive x-axis. Here's the positive x-axis to the right. That's more than 56 degrees. So it's not E either. Which one is it then? 124 degrees counterclockwise or 304 degrees counterclockwise? 90 to there, 180 to there, 270 to there, 360 to there, so 304 is something like that. That's not right. So it's not going to be B either. So just by default the answer is A, I know that. 6A. Now you could have solved this a different way. You could have gone ahead and used trigonometry, I mean using sines and cosines, to find the actual angle. So I'll show you how to do that. Let's say you'll find that angle right over there, and then let's see, that's a straight line, right? So if you've got that straight line here and we've got this angle, the distance from the x-axis is going to be 180 minus that angle theta. So we've got a 3 over here and we've got a 2 over here, and theta, so if this is theta, the side opposite the theta is the opposite side. This is the adjacent side, that's the hypotenuse. I learned as a high schooler, still remember it's SOHCAHTOA. Sine is opposite of hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. So I want to find theta. Let's see, I've got opposite and I've got adjacent. Is opposite over adjacent, therefore theta is the arctan of opposite 3 over adjacent 2, right? And we can work out that angle. That's going to be 56 degrees. Okay, so here's our picture. We can know that's 56 degrees. That's the x-axis. So all the way across here is 180. So 180 minus that 56 degrees is going to give us this angle, 124 degrees. And so when we look at the answers, 3.61 in a direction, 124 degrees counterclockwise from the positive x-axis. We knew that. We're good. That's a further confirmation, but I showed you the very first way, avoided all that complexity, all that trouble of having to work this stuff out. But either way works. You don't have to fret. 7. Some more vector equations. Vector A has a magnitude 5, okay, and points in a direction 50 degrees counterclockwise from the positive x-axis. X, Y, 50 degrees. So this is the vector A. What are the x and y components of the vector A? All I know is this angle, 50 degrees, and I know the length, 5. And that's really all I need to know, because these vectors, head to tail, purely in the x, so that would be AX, and purely in the y, AY, the component of A in the y direction, plus the component of A in the x direction, give us A. So the vector A is equal to AX plus AY vector. All right. AX vector is going to be the magnitude of that vector in the I hat direction. And AY vector is going to be the magnitude of AY in the y direction, j hat. This side, AY, is opposite, and the adjacent right next to it is AX. A sine of theta is SOHCAHTOA. Sine is opposite over hypotenuse. I have hypotenuse as well, that's 5. So opposite is AY. Sine of theta is AY over hypotenuse 5. That's sine of 50 is equal to AY over 5. Therefore, AY is equal to 5 times sine of 50 degrees, which is 3.83 according to my calculator. Make sure your calculator, by the way, is in degrees mode if you're using degrees, because you might also be using radians or gradians or some other interesting unit, but we're going to be using degrees. And then I can use cosine of 50 degrees is equal to AX over 5. Therefore, AX is equal to 5 times cosine of 50 degrees, which is 3.21. Could be this. In fact, that's all it could be. This is the answer. And let's just check, make sure. AX is 3.21. Yes, it is E. Problem 8. In 1953, the US Army field tested the M65 atomic cannon, capable of firing a shell at a velocity of 333 meters per second. That's the fastest speed that this thing could come out. That's the sound speed, 333 meters per second. How far would the shell travel if launched at an angle of 40 degrees? Okay, so let's draw a picture here. It comes out with some speed, v0, or velocity v0, and the maximum value for that, the magnitude of it, is 333 meters per second. Okay. The angle, oh good, we're told the angle theta is 40 degrees, and then this thing's just going to travel. How far is it going to travel? You could solve this with all the equations, or you could just use the range equation, which takes the various dynamic equations and then solves for the range. And I think that's what I'd like to do, because that's very nice and easy. The range x is equal to v naught squared sine of 2 theta divided by the acceleration due to gravity. So we have everything we need, because of course we know that g is 9.81 meters per second squared. So we can put all the numbers in, 333 meters per second. Always put your units in. Squared times sine of 2 times 40 degrees divided by 9.8 meters per second squared. And that works out to be 11.1 times 10 to the 3 meters, which is, of course, 11.1 10 to the 3 kilometers. Done. Question 9. How long was the shell in the air? Now we need to think a little bit more carefully. We know the final x position. Let's say we know the initial x position, 0. We know the final x position, that's 11.1 kilometers. We know the initial y position, 0. We also know the final y position, 0. Assume the shell was launched and lands at the same height. That's what was told to us. Of course, there's no acceleration in the x direction. There is in the y direction. We can assume our coordinate system is like this. So that's minus 9.8, right? Meters per second squared. So Vx0 is 333 times cosine of, and our angle was 40 degrees, wasn't it? And Vy0 is up like that, so it's plus 333 sine of 40. I don't know the time. In fact, that's the question, isn't it? T. There we go. I think that's everything I have. I don't think I have anything more. Sometimes it's worthwhile, as I said, to just spend a little time looking at your ingredients on the countertop before moving on. I don't think there's anything I'm forgetting. I think that's it. Yeah. All right, so the question is, what's the time? How long was it in the air? Now the answer is, well, let's take a look at my knives and let's take a look at my stove and all these other things. What tools do I have that I can use to combine these ingredients to find T? We'll assume we're starting, of course, at time T equals 0. Okay, I'm going to choose this one. Let's see, x equals x0 plus vx0 times t. T is x minus x0 over vx0. Let's see, I've got everything I need here. I could have x0, I have x. There's vx0, so I'm good to go. Let's go ahead and plug everything in. So 11.1 times 10 to the 3 meters minus 0 divided by 333 times cosine of 40 degrees, and that's going to be meters per second. That works out to be 255 meters per second. This gives me an answer of about 44 seconds. Now that's perfect. You could just move on. We're done. The shell was in the air then for 44 seconds, but it's not the only way to solve this problem, right? We could have gone ahead and used the y equations because we've got all these things that we know about the y equation. Let's just see if we did have enough if we chose to use the y equation. If we use the y equations, we would have y equals y0 plus vy0t plus half ay t squared. And in fact, we do have everything we need. We have y, we have y0, we have that's vy0, yes, we have that. So we've got t. Oh, well, we don't have t, that's what we're trying to find. We have ay. This would be kind of painful. We could do it, but it's kind of painful because we'd get then 0 equals 0 plus 214 times t minus 4.9 t squared. That's a quadratic equation, friends. So you're going to have to find, right, t is equal to the square root of, what's it, b squared minus 4ac over 2a, plus or minus. Of course, only the plus answer would make physical sense. And you'd find, if you go and put this all together, that would be 44 seconds. You know, I think I prefer to stick with the first solution, x. But you see, if you had chosen to start with y, it's not wrong. It would just be a little bit more complicated. And so that's why it takes patience sometimes. You know, look at your ingredients before deciding what tools you're going to use to cook the thing you're cooking. Because one way could be real easy, like that. Another way, a lot more complicated. They're both right, nothing wrong with that. But one's just a lot harder. Question 10. Given the function describing the position of an object, x of t equals 50 minus 25t plus 5t squared, determine the expression for the instantaneous velocity. Well, if you've studied your stuff really carefully, you'll remember that instantaneous velocity is equal to the limit as delta t goes to 0 on a graph of delta x over delta t. So you've got a graph of delta x like this, delta t over here, and let's say it looks something like that. V of t is the limit, so you're looking at the instantaneous velocity, you're looking at the slope. And isn't that just the derivative, dx by dt? So, you know a bit of calculus. In order to get into this course, you needed to know a little bit of calculus. So the derivative is v as a function of t is equal to dx by dt. Derivative of a constant, 50, is 0, minus 25, and the derivative of t with respect to t, plus 5 times the derivative of t squared with respect to t. That is equal to minus 25. dt by dt is 1. Okay, plus the derivative of t squared is 2 times t. So that's 5 times 2, that's 10 t. Done. So v of t is equal to minus 25 plus 10t. Awesome. Question 11. Driver A is cruising along enjoying the fall colors. Driver B starts her car at the instant that must be driver A, passes her. Okay, so driver A, I've got a picture here, cruising along. Okay, this is a velocity time graph, and you can see that for driver A, velocity is just this flat line, constant velocity. Okay, driver B starts her car at the instant he passes her, and that must be time t equals 0 because she wasn't moving, and then that next instant she is moving. She's got a velocity that's not 0. Okay, question. At what instance listed below does driver or do drivers A and B have the same acceleration? So there's more than one, at least that's the way the question's posed. There may be more than one answer. At what instance do drivers A and B have the same acceleration? Okay, at time t equals 0, driver A has a 0 acceleration. Why? Well, because remember, acceleration is the derivative of the velocity with respect to the time. It's the instantaneous velocity, and the slope, which is the definition of the instantaneous velocity of right there for the driver A, is 0. Driver B has a non-zero slope. Okay, so they don't have the same acceleration at time t equals 0. In fact, car A has acceleration equals 0 the whole time. That's just a flat line. So are the accelerations the same at time t equals 0? No, because the slope of driver A's car is still 0, and the slope here at time t equals 0 for car B is not 0. At 2 seconds, right over here, they have the same velocity at that point in time. But at that point in time, driver A is still not speeding up. Driver B continues to have a non-zero slope, so they don't have the same acceleration, so it's not there. Of course, not C then. Okay, at 4 seconds, let's take a look at that. What's the driver A acceleration? Still 0. What's driver B acceleration? It's still constant. We can actually work it out, right? It's a straight line, so it's easy to calculate the slope. It's 60 divided by 4. What's that? 6 divided by 4 is 30 divided by 2 is 15 meters per second squared. That's a huge acceleration. Oh, A for driver B is 15 meters per second squared. That's awesome. That's like you're pulling more than 1 G, almost pulling 2 Gs. You're like in a jet airplane. This car, well, I don't know what it is, but it must be pretty awesome. So at 4 seconds, no. So the answer has to be, by default, they do not have the same acceleration at any time shown on the graph. All right, that's the end of this solution session.